Hey there, friends. In 2014, Christopher Nolan directed a movie called Interstellar that became a huge hit. Space ideas like wormholes, black holes, and alien worlds were shown in this movie in a way that was true to science. The most shocking scene, though, may have been at the end of the movie. There is a moment in the movie where Cooper, the main character, falls into a black hole. The movie's black hole was called Gargantua. He and his spaceship fall into the black hole. At first, there was nothing but darkness all around him, but as he sinks further, he sees what look like grains. These particles hit his spaceship and scratch it up. There were sparks and flashes of light, and then his spaceship caught fire. As he fell into the black hole, he had to be thrown out of his spaceship. All of a sudden, he was in a space with 5 dimensions, a tesseract with 5 dimensions. It was a very strange event, a place where, by using gravity, he could talk to his past self. When you saw these scenes, you might have thought, is that really possible? Is this real in a black hole? What will we see if we go into a black hole? Let's try to understand these things in today's video.
Black holes remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong, not even light can escape.
From the outside, you can't tell what is inside a black hole.
Black holes haunt our universe, dark centers of gravity that swallow everything in their path.
Friends, let's start with the beginning of this story. Black holes have only been around for a short time. People didn't know about black holes 100 years ago. Black holes were later found thanks to Einstein's theory of relativity. Friends, the idea is made up of 2 parts. There is the General Theory of Relativity and the Special Theory of Relativity. Einstein wrote the Special Theory of Relativity in 1905. It explains how speed changes the passage of time. If you are in a rocket going too fast, time will slow down for you, in terms of the people on Earth who are not on the spaceship. To be clear, the word relative is very important, because time would not seem to slow down in space. Since everything looks the same, time seems to be moving at the normal speed. But when you get back to Earth, you'll see that time moved differently. Kinematic Time Dilation is the name for this. I also went into a lot of depth about how this works in my movie about the time traveler. Einstein's General Theory of Relativity shows that time can be slowed down by things like speed and even gravity. He came up with this idea in 1915. For you, time would move more slowly the more gravitational force you felt. As a result of gravity, time seems to stretch out, and Interstellar did a great job of showing this. The Aqua Planet is 7 times bigger than Earth, so 1 hour there is equal to 7 years on Earth. Things like this happen on the planet because it was really close to the Gargantua black hole. In other words, the black hole's gravity pull changed the time. Einstein wanted us to picture a space-time mesh to help us understand this. Like a mesh, all the things on the world are placed on it. Space-time bends because of how heavy the things are. When the mesh bends, it not only pulls real things toward it more strongly, but it also slows down time. Other types of energy, like sound, heat, and light, are also affected by gravity. Yes, that is true. This is another thing Einstein came to the conclusion of. Almost everything is affected by gravity. The force of gravity pulls not only solid things toward it, but also sound, light, and heat. Friends, this means that there may be things in the universe with such strong gravity pull that they can soak up all light. That means that if there are such things, they would be totally black. They won't be visible to us. They are so strong that not even light can get through. You guessed it, this is what black holes are. Black holes, on the other hand, were just ideas when Einstein introduced his theory of general relativity. Einstein knew that light is affected by gravity, and it was possible in theory for things to be able to receive light. Einstein didn't know there were black holes, though. Einstein himself thought the idea of black holes was strange when he was living. In theory, he knew that things like that could exist. But in theory, it's also possible for there to be no end. But he didn't really believe that things like that existed in the real world. By the time he died, no one had even thought of the word black holes. As a fun fact, Einstein's theory was based on the idea that gravity can only affect things that are moving faster than light. Gravity's strongest force is the speed of light, so we don't feel it all the time and everywhere. As an example, let's say the sun went away all of a sudden. As you know, we'll find out about it 8 minutes later on Earth, since it takes 8 minutes for sunlight to reach Earth. Einstein said that the sun's departure would also have an effect on the Earth 8 minutes later. Isn't it fascinating? After Einstein, many scientists worked on the theory of general relativity. It was made up of a bunch of equations that had to be solved in order to find their solutions. Once they did, it was thought to be theoretically proven that things like black holes do exist. For the first time, experts and scientists finally agreed in the 1960s that we would be able to see black holes in real life one day. There are things like these in space. In 1964, a magazine was the first to use the phrase black hole. But it wasn't until scientist John Wheeler made the term famous after 1967 that it really took off. The name black hole is not what it seems to be, even though it sounds exciting. Black hole, it sounds like there might be a hole there. That's not true, though. The place doesn't have a hole. Stars make black holes. That means there is something in the middle. In the stars, though, our sun is a star, there is a nuclear fusion process going on all the time. Light and heat are made by these processes. A force is sent outward by the heat being made, and there is a force of gravity at the center of the star that helps it stay living and whole. Stars stay in balance all their lives by having forces pushing outwards from the reaction and forces pulling inwards from gravity. But these processes can only happen if there is fuel. It could be hydrogen or helium. There wouldn't always be power. At some point, it would catch fire. When the fuel runs out, there won't be any forces pushing outward, and the force pulling in from the outside wouldn't be balanced by a force of the same size, so the star will fall apart naturally. Also, this will take a long time. The sun is thought to last about 10 billion years, but the next thing that happens will depend on how heavy the star is. Take a look at the picture that shows how a star changes over time. It turns into a red giant if the star's mass isn't very high, which means it was a small or average-sized star. It can then turn into a white dwarf or a planetary cloud. But if it was a big star, it would cool down and turn into a red supergiant when it ran out of fuel. The supergiant then explodes and changes into a supernova. After this, only a small core is left. A neutron star is a small core, but a black hole is anything bigger. When a star's gravitational pull causes it to shrink, its mass gets very small and concentrated. It can then turn into a black hole. To be more specific, how small is the star's volume? If a star as big as our sun turns into a black hole, it will only be 50 kilometers across in diameter. Could you picture the amount getting this small? The interesting thing is that our sun won't turn into a black hole. An Indian-American astronomer named Subrahmanyan Chandrasekhar proved this. The Chandrasekhar limit number was made by him. He said that a white dwarf could have as much mass as 1.4 times the sun. It would either become a neutron star or a black hole above that point. But since the sun, our sun, is below this limit, let's look at what a black hole is. Friends, black holes come in 3 or 4 main types. Star black hole is the first one. There are a lot of these kinds of black holes. These are the black holes that stars made. They think that there are between 10 million and 1 billion of these black holes in our galaxy, the Milky Way. And then there are the first black holes. A black hole is about the size of an atom, but they have the weight of a rock. They are thought to be about the size of an atom. Dear friends, these black holes are just ideas. We don't really know much about them. The supermassive black hole is the third kind of black hole. These black holes are very big. It's so big that it weighs more than 1 million suns put together. It also fits into a ball that is as big around as our solar system. It is thought by scientists that there is a supermassive black hole at the center of every big star. Sagittarius A is the name of the enormous black hole at the center of our galaxy, the Milky Way. Gargantua was the name of the black hole in the movie Interstellar. Plus, experts think there might be a fourth kind of black hole as well. There is a chance that the fourth type of black hole will be an intermediate black hole. These are black holes that are between the sizes of stellar black holes and supermassive black holes. But so far, no proof of it has been found. The black hole is not like a big black ball that sucks everything around it, as you saw in the movie Interstellar, and in the pictures you've seen so far and how you understand them. This is kind of how the black holes look. We know this is the black hole from the movie because it is in HD and has more depth than the picture we took a while ago. The orange ring that forms around the black hole is the first thing that you'd notice in this picture. The accretion disk is its name. This is a very important thing about black holes. As you know, black holes have very strong gravity pulls. Because of these pulls, a lot of gaseous matter and waste is drawn to the black hole and stays floating around it, along the same lines as how planets orbit around the sun because of its gravity. What makes black holes different is that their gravity is so strong that anything spinning around them goes very fast and gets so hot that the matter turns into a fluid-like substance. They turn into particles that look like fire and are hotter than 1,000,000 degrees Celsius. They are going around the black hole faster as they get closer. Because the particles are spinning so fast, they rub against each other and get squashed, which makes them glow. They give off electromagnetic waves, most of which are X-rays. The movie did a great job of showing this accretion disk. The only thing they got wrong was that it isn't orange. We can't see X-rays with our eyes. X-rays are not in the range of light that humans can see. We just call it an orange-yellow color to make it easy to understand. This disk is more likely to be blue in real life. The first picture of a black hole was taken in 2019. The accretion ring was still shown in this, with a yellowish-orange color. In the picture, the particles on one side are lighter than the particles on the other side, which you might not notice in the movie. That's because of a simple thing. The particles that are moving toward us look brighter than the ones that are moving away from us. This is because of the Doppler effect. Before you see the real picture of this black hole, you can look at this fuzzy picture and figure out which way the particles are moving. The brighter area is moving toward us, while the darker area is moving away from us. Looking back at the movie picture, another cool thing you might notice is that the accretion circle creates a trick of the eye because of gravity. The disk seems to cover both the top and bottom of the black hole. This is how it looks because of how gravity bends light. When looked at from the front, the area behind the disk is covered. The light that comes from that area has to move over it because gravity bends it. From above, the black hole will look like a normal, round disk. We can only see this effect when we look at the black hole from the sides. Besides this, there will be one last circle of light when you go into the black hole. It is called the photon sphere. This place has such strong gravity that light starts to circle the black hole. What does light come from? Photons. The photons begin to circle the black hole. So if you make it to this part of a black hole while you're still living, you might be able to see the back of your own head because the light is moving in a circle. The edge of the black hole is after this point. The event horizon is the name for this. People call it a barrier because gravity is so strong after this point that not even light can get away. After this point, everything is black. If you've already crossed the event horizon and are falling into a black hole, there's no way you can get out. If light can't get away from it, how could a person? In the movie Interstellar, Cooper's spaceship keeps going into a black hole, goes past this event horizon, and then all of a sudden he is in a place with 5 dimensions. This scene from the movie is just made up. We don't know what's inside the event horizon, so this is just a guess. A Nobel Prize-winning scientist was chosen by the people who made Interstellar to make sure that everything was scientifically correct. But it was clear that the movie turned to the fantasy for parts that were about things that science hasn't found yet, or that we don't know anything about. What will be in the black hole's middle? A theory by Einstein called the General Theory of Relativity tries to explain this. Singularity is the word for the center of this black hole idea. In the center of a black hole, where the singularity is, the curve of space-time is infinite. Remember the mesh I talked about at the beginning of the video? The space-time mesh will bend more when something is heavy. In the case of a black hole, this is bent so far that it goes on forever. As we know from the theory of relativity, gravity changes everything, including time. As the gravitational force rises, time keeps getting slower and slower. What does it mean, though, for time to slow down forever? Does this mean that if you go into a black hole and then manage to get out, the world outside would have finished for everyone else? We don't know. We can only think of ideas. What do you think? Say something below and let me know. People have come up with some interesting ideas. Light is swallowed by a black hole, so we can't see inside it from the outside. According to one idea, light bounces off of the event horizon several times before it reaches the singularity. So it's possible that things would be able to be seen inside the event horizon. This picture is the only thing we know for sure about black holes. This picture was taken on April 10th, 2019, by the Event Horizon camera. This pretty much showed that black holes exist, about 100 years after they were shown to be true in theory. One thing is for sure, if you fall into a black hole, the gravity pull will likely break you up into a million pieces. You're going to die in a second. Still, friends, you don't need to be afraid of black holes. A long time ago, a lot of people thought that black holes ate all the matter in the universe, kept getting bigger, and finally wiped out the whole thing. That's not how it works, though. As I said, there is an enormous black hole at the center of every star, and all the planets and stars that are close to the black hole move around it. This is like how all the planets in our solar system move around the sun. At the center of the world, the same thing takes place, but it's much stronger. In conclusion, you will be safe and sound if you keep your distance from a black hole or if you keep your distance from other people. The idea of 5 dimensions, which was talked about in Interstellar, is also an interesting one. In another movie, let's talk about it. That's all for now. If you like this video, you can see more about space. If you haven't already, watch the video about time travel. There, these ideas are explained in more depth. Thanks a lot.